know what you don't know, write down the questions, be like, I don't know how to do this question. Go and learn and make sure you know how to do that question. Come back and practice it until you're consistently getting them all right. Um, if you don't understand why you're doing these questions, you're just doing them. This is going to be a big issue for you if you come across a question that you haven't seen before. Whilst the questions will be similar, you need to understand what you're doing so that if something little changes in the question, you can adapt it, adapt the skills you've learnt from the other questions and to be able to answer the question on the day. Some other general exam advice as well, because I get asked this a lot because I've sat way too many exams in my entire life, is you should not technically study on the day of the test and even the night before. You should be relaxing, chill, get some good sleep. If you don't know it by then, you're not going to know it now. Also, drinking like iced water can really help calm you down and better focus in these situations. But the only way to get rid of anxiety is to be 100% confident that you know how to answer them. Once you start doing the first questions and you're like, okay, I have practice, I have worked out, you'll get confident and you'll feel that throughout the test. Um, Now, I was going to break these down into each of the sections as well, just to kind of discuss um, how to best approach them more specifically. So, for numerical reasoning, there's a bunch of different question types you could have. Like, is it worded problems that that test provider likes? Is it algebra? Is it the missing numbers? Knowing that is very key, and you can get it from our website, but you can also just look it up on their website. They will tell you. Um, I get asked all the time about like other where you can get other aptitude questions, and if the answer to that is you should look at who the provider is, look at what the question types are, and then actually look at who's giving you the right questions. We're giving you the right questions, but you don't have to believe me on that. You can verify that for yourself. Um, Other things to know for numerical is just your basics, multiplication, division, percentage, fractions, ratios. All those things, they're pretty basic. You can practice them in the aptitude guide, or you can also just download a bunch of apps on your phone that are like quick math apps. And that kind of thing is going to really help you because when you now know confidently what 7 times 7 is, that's going to save you so much time in the test. Um, the other thing as well with numerical reasoning is most of the time you probably work out most questions if you had unlimited time. But the trick is to fight against the clock. Um, and the other thing as well is you need to practice getting out what's the key information from the question. For like a worded question like here on the side that I have, any kind of number in it, you should probably be using, right? And if you get to the end of this and haven't used all the numbers in the question, you're probably missing something. Unless it was like um, the number was to do with like the category or something else. But you need to go through and be like, okay, I need to use this part. This is a keyword here because that's the average and we know what that means. And then there's also these numbers here. You have to be able to get them out. Or if it's asking, okay, this is asking what the other number is, but you can have questions like, what's the percentage? What's the percentage change? Those words in maths have key meanings, and knowing what those means will really help you break down. Another important thing as well is because it is a time test, you should try and use shortcuts and estimate and eliminate options. And this is going to be the quickest way to save time. So you could be like, oh, okay, I know it has to be roughly this size. So, for example, this question, if the average is 12 and these are your numbers, none of them are even at 12 yet. So the average being 12 means the missing number needs to be more than 12 to compensate for these other numbers being less than 12. So I could look at the multiple choice for this, which I haven't put here, but instantly go, okay, needs to be more than 12, probably decently more than 12. I would expect the answer to be about 20. And that can help you obviously pick up the answers quickly, particularly when they're further apart. But it also means you don't have to get caught up in decimals or fractions as much. You can just be, okay, it's about this. I can pick the answer from there. And the main thing is don't make the same mistake twice, which obviously that's a bit of an extreme rule, but if you're gonna practicing, you get something wrong, you should sit down and work out why you're wrong on that question and try and work it out and actually learn from your mistakes. So next section's abstract. With abstract, I feel like people struggle with this a lot of the time because they get really overwhelmed with the visual clutter in the question. But in abstract reasoning, there's only really five different answers. And that applies to all the states. They have their own answers within them, but based on each question type, there's maximum five answers. And if you know the question type for your states, then you can just learn the five different answers. And then the key then is to apply them to each of the different questions. The only thing that changed that abstract reasoning is the color and the shapes, right? The pattern itself will always be the same. And so you got to look for those key clues that identify what the pattern is. So, for example, this one here on the side, there's in each square, there's lots of the same shape, um, two different colors each time, and the number is changing each time, right? So this one here is going to be a counting based question because there's heaps of the same shape and the number of that is changing. So the solution for this will be based on counting how many of each shape there are. There'll be other ones, well, where they have the exact same number of shapes in each one, in which that case it's more likely to be a tracking style question where you need to follow the shape around. Um, Often as well, to get the final solution for abstract is there's often two patterns in the question. So one of them, like this one here, you have to count both the purple and the yellow technically to get the answer. This one is a bit easier because you can tell straight away. But say for instance, there's like two here, and then there's four and three, and like you have to work out technically the missing number as well. So there's like the shape and the number of it for each different one in here. You should be doing this via elimination because that's the only way to guarantee, well, not guarantee, but ensure that you've thought about everything that's needed to be thought about. By doing it via elimination, you might found one rule and then you write, oh, wait, I actually can't differentiate between these two answers that are left. And that means that you need to go back and find the second pattern that's in it. You should also just approach it one shape at a time. You don't need to take into account the whole thing all at once, because that can be very overwhelming. And that's the point of the question, is just to overwhelm you. But if you break it down, it's a lot simpler. In terms of verbal reasoning, there's only a couple different types of verbal reasoning questions. And again, just know what's needed for your state. But this could be analogies, it could be synonyms and antonyms, or it could be reading comprehension. Pretty much everything falls in those categories, and most states will use the analogy style questions. For the analogy ones, you have to do it by elimination, and you need to stay objective in this and cross the board. It's not about what you think the answer is, and this is more important for reading comprehension. It's about what you have been told in that thing. So if the passage is all about how the moon is what gives the earth light, even though you clearly know that that comes from the sun, you have to do it based on what the passage is saying, not what you know personally. And these is just an example here of the analogy style questions, which if I get time, I can come back and break down how to solve as well. Then you have deductive and critical thinking sections, which not all states have, but it seems to be kind of an emerging section that they have. And for these ones, you really should draw a solution to solve the answers. So some strategies you can use for this is what's called Venn diagrams or number lines. And then the elite members will know what I mean by that, hopefully, for the right states. But it's about drawing out the written problem in front of you so that you know you can see it in front of you and you're not trying to process all these abstract sentences all at once. And you see what I mean if you read that example there. This is also back to my previous point about you have to focus on what the sentence is saying, not what the truth is or what the absolute truth is. Um, it just has to be based on what they're saying there. In terms of like some of the other style questions, so there's ones that are like some or actually this one's actually has it. But words like always or never pretty much tell you that the answer is probably going to be false. because always and never are very what I call strong words. Um, um, whereas a word like sometimes means that it's more likely to be true or cannot say, because it's harder to disprove a word like sometimes. It's very easy to disprove an always or a never or only as well. Um, and the other thing as well is that you want to find links between questions or different statements, which is not the best example for this one, but how these ones both have melds in it. Some sentences you might not be able to process all the options unless you start linking two of them together. And then mechanical reasoning is an interesting one. And I think it's quite simple, but at simultaneously quite difficult. And it can be, I imagine, very, very infuriating to all of you some of the time. The trick to numerical reasoning is that you need to answer it based on the physics principle that underlines the situation. For example, gravity, heat flow, electrical currents, fluids, forces. They have set rules in physics, which might seem very counterintuitive, but knowing those rules is going to be how you solve these questions.